Okay, we're back at it to finish off lesson 1. Second part of this is going to deal with solving quadratic equations. The first part was properties of numbers and types of numbers. So there's a little minds on here. I would like you to think about what the answers to these 3 questions might be. I'm going to recommend, I forgot to mention that in the first video, that you should actually pause the video and do some thinking. So I'm going to ask you to pause the video at this point in time, do some thinking. I'll pause it while I'm doing my thinking. Okay, we're back, and I'm going to give you examples. So if it says simplify, it would not be an equation. So for example, maybe 6x plus 2y minus 8x plus 5y. That's something that could be simplified. If it means solve, we're implying it's some kind of equation. So 2x minus 10 equals 5, or maybe it's a quadratic. X squared minus 2x plus 4 equals 12. What form would immediately give the solutions to the equation? Factored. Equal to 0 though. So if it was a times b times c is 0, then a is 0, or b is 0, or c is 0. All right, moving on to slide 2. Try and pick up the pace. If a quadratic can be factored, that means it's possible to rewrite it. This isn't monic. We'll have to presume that a can be something other than 1, which means we're going to have non-monic binomial factors here, right? R and t are something other than 1. So if it's factorable, then it's possible to write it like this, which means that r plus s has to be 0. And that is going to give that rs is negative s, which gives x is negative s over r. Or we have tx plus u is 0, so tx is negative u, so x is negative u over 2. That shouldn't be new. That's straightforward. All right, a student has solved a quadratic as follows. Do you agree with their work? Does it seem logical? If not, what error has been made? Again, I'm going to recommend that you pause the video, give this some thought, and then I will tell you what the answer is when I come back. So I'm going to pause as well so I can do some thinking. And we're back. Does the student's work seem logical? So what the student has done is taken this and they factored. So they now have, if I just change this to, focus on one number, a second number, the product of 2 numbers is negative 3. Therefore, we're saying that the numbers need to work out to 0. And of course, 0 times a number would never be negative 3. So this is not logical. If AB is negative 3, then what I can say for sure is A is not 0 and B is not 0. What they should have done instead was write this as 6x squared minus 19x plus 3 is 0, and then attempt to factor that quadratic. All right, continuing on to slide 4. So now we've written it the proper way. It should have been written as 6x squared minus 19x plus 3 equals 0. Cautionary tale when we jump back to there. Do not do this on a test when I give you a test. Some students do this. This is really partially factoring. When you factor, this has to be equal to 0 on this side. So now that it is equal to 0, I'm trying to find 2 integers that multiply to give 6 times 3, which is 18, and they add to give negative 19. Now I'm going to remind you that I showed you before we went off on March break that once you find your 2 numbers, you could go straight to factor form by writing ax plus s times ax, ax plus r times ax plus s all over a. And I proved why you could do that. If you don't remember how, contact me, and then I will send you a link to that. So 2 options of factoring down here. We've got using this method above. A is 6, so 6x. Our numbers, well, we found out what our particular numbers were. What did we say our 2 numbers were? Actually, I guess we didn't discuss what the 2 numbers were. So the 2 numbers should be negative 18 and negative 1. Negative 18 times negative 1 is positive 18. Negative 18 minus 1 is negative 19. So using this method, which I think is faster, and that's the method I would like you to use, 6x minus 18, plugging into here. 6x minus 1, plugging into here. Root or our number 1 in here, negative 18, number 2 in there, negative 1, all divided by a, all divided by 6. And what will happen now is you will be able to factor out enough numbers out of here. In this case, they all come out of the first binomial, but it could be a combination of the two. When you factor the 6 out of there, it will reduce the 6 out of here. We now have x minus 3 times 6x minus 1. Again, I would expand quickly to make sure I was right. 6 times x, 6x squared, minus x minus 18x minus 19x plus 3. I'm back to where I started from. And this gives roots of 3 and 6. The other way to do it, I know some of you love this, this is called decomposition. 16x squared minus 18x minus x. We decompose the middle term into negative 18x minus x, and then we common factor a 6x out of here. We common factor a negative 1 out of there. We have a common binomial now, which we then factor, and we get to the same place. This is much faster. This is the method I think you should learn if you're heading off to take a math course in university. How could we verify the solutions were correct? You're just going to plug a 3 into here, and you should get 0 back. Plug in a 1/6 into there, and again, you should get 0 back. Solving something by using the quadratic formula. Maybe I'll just walk you through this. If we're going to complete the square, we need it to be monic, right? Right now it's 2x squared, so I'm going to factor a 2 out of the first two terms, and I'm going to get 2 times x squared minus 3x. Now, when I expand this, I'm going to have 2 terms in x, right? So I'm going to need to take half of this to get it to work, and I did draw a picture of this for you. Maybe I'll just draw a quick picture. So we have x squared, and we have 3 x's. What I would like to do is put 1x on each side, and then half an x on each side, and now the dimensions will be the same. That's x plus 1.5, and that's also going to be x plus 1.5. So that's why we're splitting that in half, because we're trying to construct a square. So half of 3 is 1.5. So now x minus 3/2 all squared. Now where is this coming from? It comes from this corner here. When you fill this square in, you're going to see that your dimensions now are going to be 1.5 by 1.5. And remember, 1.5 was 3 over 2. So what happens is I now have this area here that was 3 over 2 by 3 over 2. So now I'm going to take it away, because this fills in this corner. And when I minus 9/4, which is 3/2 squared, I'll be taking that away. And then I'll be back to where I was, which is plus 5. So now I'm going to distribute 2 times that, 2 times that. Get a common denominator. Negative 18 over 4 plus 20 over 4 is 2 over 4. Which is a half, but I'm going to leave it as 2 over 4 for now. Bring this over to this side, because we're now going to isolate. Complete the square, now we'll isolate for x. So bring this over, and then the next thing we're going to have to do is divide by 2. So if we divide by 2, this is going to become a quarter. Now I take the square root, so I'm going to get, remember there are 2 square roots, so plus or minus the square root of negative a quarter. Then we have x minus 3/2. This is going to become 3/2 plus or minus the square root of negative 1. The square root of 4 is 2, so that's over 2. And I'm going to get 3 plus or minus the square root of negative 1 is I, all over 2. And this part over here, I'll let you look at it and follow through it, and you can ask me questions if you want. If we were doing this face-to-face, I would walk you through this, but I'm not going to walk you through this on a video solo. We are basically completing the square on the standard form quadratic, and that's how you derive the quadratic formula. So try that on your own. Contact me if you have any questions. All right, solve the following by using the quadratic formula. And then maybe we'll try and complete the square on the second one. So I'm going to give you some time to think about that. I almost forgot to do that. So I'm going to pause. Let's use the quadratic formula on this one, and then let's complete the square on this one. So again, I'm going to pause to do some thinking, and I'm going to let you do the work. All right, hopefully you took some time to do your thinking. Plugging into the quadratic formula, x is negative b, negative 4 is positive 4, plus or minus the square root of b squared is 16, minus 4, the product of a and c is negative 15, all divided by a, which is 3. This is 4 plus or minus the square root of, what's that, 76 over 3. And now let's see, 2 goes into that, and that leaves us with what, 38? And yeah, there's no perfect square factors of that, so we would leave it like that. On the second one, if we have to write out both roots, I guess we'll do it that way. 4 plus the square root of 76 over 3. And x is equal to 4 minus the square root of 76 over 3. All right, off to this one. First thing we're going to do is factor out that negative. We're going to get x squared minus 5x minus 8 is 0. Now we're going to take half of this. So that's x minus 2.5 all squared. Now, I was talking about that little square, so I put 2.5 on this side, and then putting 2. That's a little half. Squeeze, that one's a half. Now I've created this area here. That area is going to have dimension 2.5 by 2.5. So I'm now going to have to subtract 2.5 all squared. And then minus 8 is 0. This is going to give me negative x minus 2.5 all squared. Minus 6.25 minus 8 is 0. Distributing negative x minus 2.5 all squared, that becomes plus 6.25 minus 8 is 0. And this is going to give us negative x minus 2.5 all squared. And then what are we? Minus 1.75 is 0. And now continuing to isolate, negative x minus 2.5 all squared is equal to 1.75. Extend the page. X minus 2.5 all squared is equal to negative 1.75. X minus 2.5 is plus or minus the square root of negative 1.75. And then we're going to say x is equal to 2.5 plus or minus the square root of negative 1.75. And maybe we should clean up the decimals there. So that is 7/4, right? So that's 7/4. So x is equal to 2.5 plus or minus the square root of 4 is going to be 2. So there's a 2 here. Got the square root of 7. So root 7, and then the square root of negative 1 is going to become I, and I can write it that way. Extending so that you get the same answer if you plug into the quadratic formula. 2.5 is 5 over 2. So this is going to become 5 plus or minus root 7 I all over 2. And I might have made a mistake on that, but bearing in mind, I don't want to belabor this. The correct solutions are online in case I made a mistake doing it this way. I did say go into the quadratic formula, but I wanted to try something different. All right, so we're now going to be thinking about when you could expect real roots, when could you expect complex roots, when could you expect rational roots, how could you figure out the number of unique roots, and what do the roots tell us about the graph. So on the next slide, you're going to take some time to figure out what the roots are by using Desmos, or you can use Symbol Lab, that link I've got there. And then you're going to fill in this. If it can be factored, you're going to factor it. You're going to tell me what the discriminant was, how many roots, and what type the roots were, either real or complex. All right, again, you're going to pause the video at this point in time. You should have that note in front of you. I expect that you're going to be filling that in now. And I'm going to pause right now. All right. Hopefully you filled all of this in. I'm just going to jump to the next page where it was filled in. And then I'm going to take a look. We're going to come over here and we're going to see when it was factorable. Look what was true in all the cases where it was factorable. All right. So every time it was factorable, what kind of numbers are those? That's what you should be thinking about. Those are all special kinds of numbers. When they weren't factorable, but we had real roots, that was these cases right here. And then when they had complex roots, that was these cases. And then you're sort of going to summarize. So you should give that some thought. I'm just going to pause again. while you think about what kind of numbers are we seeing there for the discriminant, and then I'm going to jump into the next slide. So again, I'm going to give you some time to think about that. You should pause the video. Okay, we're back, and then I'm going to give you a bit of summary on the next slide. I'm going to look here first. These are perfect squares. And when the discriminant is the perfect square, the quadratic is definitely going to be factorable. If the discriminant is positive, actually I should say positive perfect square. If the discriminant is a positive non-perfect square, it will have two real roots, but it will not be factorable. And when the discriminant is negative, and it doesn't matter whether it's a perfect square or not, we're going to get complex roots, because that's a quadratic that is not going to touch the x-axis. So in summarizing, if b squared minus 4ac is greater than 0, you do have two real roots. If b squared minus 4ac is 0, then you have one real root. There are two roots, but they're equal to each other. So this is getting two distinct real roots. This is getting one root repeating twice. If the discriminant is negative, there are no real roots, but you're going to get two complex roots. And if b squared minus 4ac is a perfect square, the two roots are rational and the quadratic is factorable. So I typically check this quickly to decide whether or not a quadratic is factorable. I plug into b squared minus 4ac. If it's a perfect square, I know it's factorable, so I can then try and look for those numbers. If it isn't, you're wasting your time looking for the numbers because the numbers don't exist. All right, next slide. Let's solve that by completing the square. Okay, I am going to pause and I'm going to allow you to complete the square on this. Completing the square is a very important technique for university. Okay, we're back. And again, we start by, and again, we're solving by completing the square. So I'm going to complete the square first. So take half of 2 is 1. So x minus 1 all squared. And then what I need to do is subtract 1 squared. Because, again, putting a tile on this side and a tile on this side, we've now filled in that area. And the dimensions of that are 1 by 1. I'm going to have to take that away to stay balanced. So plus 3 is 0. That gives me x minus 1 all squared. Plus 2 is 0. So negative 1 plus 3 is positive 2. We get x minus 1 all squared is equal to negative 2. We're now going to get x minus 1 is equal to plus or minus the square root of negative 2. We're going to get x is equal to 1 plus or minus the square root of negative 2. And we're going to write that as x is 1 plus or minus, I think this time I'm going to write it as I root 2. And remember, the square root of negative 1 is I. And you will be expected to rewrite this using that technique and coming down to there. So if we think about this, does this make sense, right? It has complex roots. So this is a parabola that opens up and it has its vertex at 1, 2, and it opens up. So clearly it doesn't cross the x-axis, so it has no real roots. All right, on to the next question. You are to solve this one by factoring. So I'm going to pause the video. And again, I'm going to hope that you pause the video and you actually spend some time working on that. All right, I just lost my controls there for a bit, so we probably had a few minutes of dead air, so please just ignore that. All right, so 3x squared minus 4x minus 15 is 0. So I'm looking for two numbers that add to negative 4. And now they need to multiply to give us what? Negative 45. What are our two numbers that multiply to negative 45 and add to 4? So let's do negative 9 and positive 5. They multiply to negative 45 and they add to negative 4. And then I'm just going to jump straight into a, x, one number, negative 9, a, x, second number, positive 5, all divided by a. That's going to be 0. Notice I can factor 3 out of here. 3x plus 5. All divided by 3 is 0. And that gives me x minus 3 times 3x plus 5. Always a good idea to do a quick mental check. So that times that is 3x squared. That times that is 5x. That times that is minus 9x. So there's my minus 4x. There's my minus 15. It is indeed that. We do have equal 0 over here. And now our conclusion. Therefore, this is 0, and that gives me x is 3. Or this is 0, and that gives me x is negative 5/3. All right, that one's done. On to the next slide. Solve that using 2 different methods. So again, I'm going to pause. I'm going to give you some time to think about it. And then I'll show you a method I'm going to use. Okay, we're back. First thing I'm going to do with this is I'm going to bring the half over. Minus the half is 0. And what I'm going to do right now is I'm going to multiply everything by 12 so I can clear those fractions out of there. And that is going to give me 12x squared minus 14x minus 6 is 0. Now let's just check. 12 times 1, 12 divided by 6 is 2, 2 times 7 is 14, 12 divided by 2 is 6. And then for my method, and I'm only going to use one method here, I'm going into the quadratic formula. X is equal to negative b, which is 14, plus or minus the square root of b squared, 14 squared. I think that's 196, but I just want to check quickly. Get that calculator out. 14 times 14 is, that was indeed 196. 196 minus 4 times the product of A and C is negative 72, all divided by 24. So x is equal to 14 plus or minus 12 times 6 is indeed 72. Yes. All right, over to the calculator. Let's clear that out. 4 times 72 equals plus 196 equals 484. All right. The square root of 484 all over 24. Gonna have to come back here for a second because I'm not sure what goes into this. I'm gonna try 16. Divide that by 16. No, times 16 equals, we know 4 goes into it. So 4 goes into 121. Oh, so that looks like that was factorable, right? I should have checked that because that is a perfect square. Clear. 484. Take its square root, and we are 22. Well, how do you like that? So now x is 14 plus or minus 22, all divided by 24. Extend the page. And now we're going to get x is equal to 26 over 24, or x is equal to negative 8 over 24. So x is equal to 13 over 12, or x is equal to negative 1/3. All right, now that's factorable. So for your other method, why don't you try and factor that? See if you get the same roots I did. If you don't, that means I made a mistake. The solutions online are going to be correct. All right, let's go to the next one. Now we're going backwards. So suppose I tell you to find a quadratic equation that has some specific roots. Again, I'm going to pause, give you some time to think about it. All right, we're back. So I think I'm going to start by saying this. We know that x is equal to negative 2/3, and we know that x is equal to 1/5. If I cross multiply, I'm going to get 3x is equal to negative 2, so I'm going to get 3x plus 2 is equal to 0. This is going to give me 5x is equal to 1, so 5x minus 1 is equal to 0. And now I have my two factors, so I simply need to just do 3x plus 2 times 5x minus 1 is 0 to get back to the original equation. I now have 15x squared minus 3x plus 10x minus 2 is 0, and that's going to give me 15x squared plus 7x minus 2 is 0. All right, similar idea on the next slide, just made a little bit more complicated because now the roots aren't rational numbers. So again, I'm going to pause, give you some time to think about it. You should pause as well. Okay, I'm going to presume that you took some time to work this out on your own. I'm going to start the same way. X is negative 2 plus root 6, or x is negative 2 minus root 6. Those are the two roots, negative 2 plus root 6, negative 2 minus root 6. This gives me x minus 2 minus root 6 is equal to 0. Sorry, that's x plus 2. X plus 2 minus root 6 is 0. X plus 2 plus root 6 is 0. So now we need to distribute across two 3-term pieces. And if we do this correctly, all of the irrational components will disappear. So there should be 9 terms, 3 by 3, 9 terms. So x squared plus 2x plus root 6x. That times that, that times that, that times that gives me this. So actually you probably can't see that. So that times that, that times that, that times that gives me these 3 pieces. I'm going to change pen colors now. Land into the next one. Plus 2x plus 4 plus 2 root 6. So that times that, that times that, that times that. Alright. Change colors one more time. I'm going to look at this guy now. Minus root 6x minus 2 root 6. And that times that is minus 6 is 0. And again, that would be that times that times that, and that times that. Alright, now let's see how this cleans up quickly. So, okay, so let's see. Root 6x, negative root 6x. 2 root 6, negative 2 root 6. So I have x squared. I now have 2x, and 2x is 4x plus 4x. So compare that. Then we now have 4 minus 6 minus 2 equals 0. Okay, if I want to make sure I'm correct, I could probably quickly plug that back. You could probably plug this back into the quadratic formula and see if you get that back for the root. Okay, moving forward. All right, again, I'm going to give you some time to think about these equations. Can you have one real and one imaginary root? Can you have one rational and one irrational root? And again, I'm going to pause and give you some time to think about this. All right, so hopefully you had some time to think about this. First thing I want to do is I'm going to write down the quadratic formula. It says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, we started with a quadratic of this one. And a and b and c are actually going to be rational numbers. So let's take a look at who's going to dictate what kind of number we get back. If these are rational numbers, then this is going to stay rational in this calculation. Dividing by 2 is still rational. Dividing by that is rational. So these are having no impact. This is still going to stay rational. So that means this is going to determine what kind of roots we end up getting, right? Now, if b squared minus 4ac is less than 0, we get this. What we wanted was an imaginary root. But in order to get a real root, then we need b squared minus 4ac to be greater than 0. And earlier you looked at properties of numbers called trichotomy. I'm going to write it over here. Which says if you're going to compare two quantities, and we are comparing this to 0, that only one of these can be true. They cannot be both simultaneously true. So the property of trichotomy is going to guarantee that you can't have one real and one imaginary root. Let's come down here. Can we have one rational and one irrational root? So let's think that through. In order to get a rational root, we need b squared minus 4ac to be a perfect square. Because up in here again, the square root of a perfect square is going to make this a rational number, and these are rational numbers, so if you operate in rational numbers, it will return a rational number. Now, in order to get an irrational root, I'm going to need this thing, b squared minus 4ac, to be a non-perfect square. And these are mutually exclusive. Whoops. Let me undo that. All right. These two concepts mutually exclusive. Which means you're one or the other. So you can't be both simultaneously. So that's not going to be possible. Now finally on to the last slide. Why is it possible for a quadratic to have no roots and a line must have a root? All right, I'm going to pause. And you're going to think about that again. All right, so hopefully you had some time to think about that. And the key ideas probably would come from, I guess, the first unit we were looking at, or maybe the second unit. We're looking at sort of end behaviors, right? So line ends head in opposite directions. So we can go from Q3 to Q1, or we can go from Q2 to Q4. So the line can start here, and it can end there, or it could start here and end there. Because the lines, their ends head in opposite directions, you're going to be forced to cross the x-axis. However, a quadratic the ends head in the same direction. So let's think about that. So let's think about a quadratic that opens up but's been shifted up, no roots. Or a quadratic that's opened down and has been shifted down. So open up, shift up, no roots. Open down, shift down, no roots. All right, so that ends lesson 1, and sorry, but the length of these videos seem to be very long, and I'm trying to go really quickly. All right, so I'm going to stop recording and then try doing lesson 2 for tomorrow.